Hi, my name's Matt and I'm a doctoral student in mechanical engineering interested in making digital fabrication more accessible to all students. One project that I've been working on was developing an augmented reality interface for a CNC machine. For those who don't know, CNC stands for Computer Numeric Controlled and is a form of digital fabrication that allows you to carve or cut a computer-generated shape out of a material. A mill or router in the CNC machine works kind of like a drill, but it's so powerful that the machine can be dragged over a material to cut it away layer by layer. CNCs are great because unlike a 3D printer where you're melting layers of material together, the pieces you cut will be sturdier because they start as a solid material. Common materials used are wood, soft metals like aluminum, and PCB boards for electronics. Another advantage is that unlike most laser cutters that can only cut through material up to a quarter-inch thick, a CNC can cut through any thickness material as long as it fits in the limits of the machine. A disadvantage of a CNC is that you have to know some information about the material you're cutting to control the speed the machine is moving. Unlike a 3D printer that just takes in an STL file then adjusts the settings based on the printing material and the resolution you want, a CNC needs a special toolpath file generated from your design. If things are not set up properly, you can break the bit or damage the machine. Luckily, there are software tools that include the proper settings and generate toolpath files just by inputting the bit size and material you're cutting. When setting up a CNC, the user is responsible for making sure the machine is in the proper starting position. Then it will follow the instructions of the toolpath absolutely. The augmented reality software interface I developed tried to address these difficulties by allowing the users to check the size and position of their design directly overlaid on the material they're cutting. I developed the interface using National Instruments LabVIEW software and implemented the system on a Shapeoko CNC router, a build-it-yourself kit that costs $1,000. As you can see from the screen capture of the interface, the first step is to home the machine to let it know where it is. The next step is to clamp your material to the cutting surface. I developed my own clamping mechanism using a normal hand squeeze clamp and a bracket in the back left corner. The user can clamp their material in less than 5 seconds using this system. The next step is to calibrate the camera to the CNC position by placing a checkerboard grid on the back left corner of the material. The system I set up requires the user to select the grid, and it uses image processing to find the corner points, which are known positions. I created the system so that it calibrates to the top surface of the material, and made it so you can select any sized region so it works on any sized material. Once calibrated, the user can click on the image and see a drawing of their toolpath overlaid on the image of the material. When the user is happy with the placement of their design on the material, they can click Move to Drawing and the CNC will move in the X and Y axis to the proper starting position to execute the cut in the desired location. The next step is to lower the machine to the surface of the material by clicking the -Z button. Once the bit is just at the surface of the material and everything looks good, the user clicks Reset 0 to make this the new starting position of the machine. Then all that's left to do is turn on the router, close the lid, and click Start Cut. If everything was set up properly, the user should then be able to watch as the machine starts to trace the lines on the image as it cuts away the material layer by layer. The system is very far from perfect and acts more of a proof of concept for this augmented reality feature, but for the region that was used when calibrating, the router traces the image with a fair degree of accuracy. I was able to test out an earlier version of the interface this summer with elementary school students during the Girls Design and Engineering Week workshop at the CEEO. They were introduced to an online application called Easel that has both CAD and CAM capabilities, meaning that you can create designs and generate CNC toolpaths all in one program. Once you create a design and input the desired depth of the cut, you can select the bit size and material, then the software will generate the toolpath for you. It will also warn you if the design has features that are too small for the selected bit size. The girls were all very excited by the tool and the chance to carve their designs out of wood. When used well, CNC machines can produce pieces that are of extremely high quality, and it's very powerful for students to see something they designed themselves produced in such a professional way. Although the use of my interface required a bit of coaching, it was a cool way for them to see how their design would look on the material before cutting it. A few companies are now developing exciting machines and interfaces that help lower the barriers to entry to milling. A few of the products I'm excited about are the Other Mill, an all-enclosed machine that is especially good for milling PCB boards, and the two machines produced by Inventables, the same company that created Easel, called the X-Carve and the Carvey.
The X-Carve is a customizable, assembly-required kit for higher-level machining, and the Carvey is an all-enclosed system that can be controlled directly by easel, which makes it very easy to use. As more commercial technologies come to market that help make it easier to use, I think CNC machines will be a great educational tool for empowering students to be designers and engineers. Thanks for watching, and please feel free to contact me with any comments or questions.